Okay, folks, so I wanted to come in with a video today because today we've been solving problems like this, where we have been graphing these and we have been looking for where the lines cross. We did that all this week. We would graph these and there would be two lines and we would look where they would cross and then we would label that point with an X and a Y. Okay? That can be a little bit tedious, number one, to do it that way every single time, to have to make out a graph. Plus, if, we noticed, especially with me doing it on the whiteboard, sometimes it was hard to see exactly where the lines were crossing, to get the precise point. So I'm going to show you an algebraic way to do this that we don't have to graph. We can find the point that they have in common without graphing. And this is actually called a method called substitution. So what we can do here is we know that we want to find out the point they have in common. Both of these equations are equal to y. So what we can do is we can just put them equal to each other. 6x plus 10 equals 8x plus 14. Put them right next to each other. We call it substituting one of the equations in for y in the other equation. But ultimately, all you end up doing is putting them next to each other. And now this should look familiar because we solved equations like this the previous week. This is why we reviewed these types of equations and solving these types of equations. So now all you have to do is solve this for x, and you'll have the x coordinate where these two equations, these two lines meet. So I should know how to solve this by now. I'm going to bring the 8x over here with the 6x. Anytime I move across the equal sign, I always have to do the inverse. So I'm going to minus 8x. So 6x minus 8x, right, is negative 2x plus 10. This is gone, equals 14, right? And now I finish up. I minus my 10. So negative 2x equals 14 minus 10 is 4, right? And then I just end up by dividing by negative 2. And so it looks like x comes out to be negative 2. Okay? So this is a way to figure out what's the point that they have in common without having to graph it. Okay? Now, however, remember when we did these problems by graphing, we were finding a coordinate. Right? So we were finding not just an x, but we were finding an x and a y. We were finding a set of coordinates, a coordinate pair. So you're not done the problem yet. You have to take that x and you have to put it back into one of the equations to figure out what y is. You can put it back into either one. It doesn't matter. So I'm just going to put it into the top one. So y equals 6x plus 10. So in the place of x, I'm going to put the negative 2. So y equals 6 times negative 2 plus 10. And now I get 6 times negative 2, that's negative 12 plus 10. So it looks like y is going to come out to be negative 2 as well. So you're not done these problems until you get both the x and the y coordinate. Because remember, when we did it by graphing, we were finding a coordinate pair, an x and a y. So you can't just give me the x. If you want to write your answer this way, that's fine. If you want to write your answer like we would, negative 2, on the graph, you could do that as well. Okay? But this is a way to do these problems algebraically so you don't have to make the graph every time. We're finding the same answer we found on the graph, but we're just saving ourselves the time of making a graph. All right, and this is a more precise way of doing it in case we can't quite tell where the points are crossing. Let's do a couple more, make sure you got it. Okay? So let's say y equals, I'll write these here, y equals negative 3x minus 15, and y equals 6x plus 12. Okay? So again, this sets up just like the other problem. Now normally we could graph these. We could graph these and find out where they cross, but I don't want to worry about that hassle. So all I'm going to do is I'm going to take the top equation, and since they're both equal to y, I'm going to write them next to each other. Negative 3x minus 15 equals 6x plus 12. Put the two next to each other, and now you're going to solve for x. Okay? And again, at this point, you should be, I've already seen some of your work, so a lot of you are pretty good at solving these types of equations. We've got to get all the x's on one side, so I'm going to move the 6x over here with the minus 3x. Anytime I move across the equal sign, remember, you got to do the opposite, the inverse, so I'm going to minus 6x. Watch your negatives. So negative 3x minus 6x, that's negative 9x minus 15, and then on this side we have 12. Right? And now I'm just going to finish up my solving. Get rid of the minus 15 by adding 15. So negative 9x, and then you're going to get 27. And then since it's multiplication, you divide by negative 9. And watch your negatives. X comes out to be 27 divided by negative 9 is negative 3. Okay? But again, remember what I just said, previous problem, we're not done. Because in all these problems, you're actually finding the coordinates pair where they cross, the point on the graph where they cross. So you need the y. So I'm going to take one of these equations. It doesn't matter which one, because it's the point they have in common. So you could pick either one. I'm actually going to pick the bottom equation because it has less negatives and minuses. So I'm going to say the bottom equation, y equals 6x plus 12. And I'm going to plug negative 3 in for x. So y equals 6 times negative 3 plus 12. And figure out what y is. So 6 times negative 3 is negative 18 plus 12. So it looks like y is equal to negative 6. So y is equal to negative 6. And that's your complete answer. X is equal to negative 3, y is equal to negative 6. Again, you can write the answer that way, or if you want to write it the way we did on the graph as a coordinate pair, you can do that as well. I'll accept either one. But remember, you're not done until you find the x and the y. Because remember what we were finding when we were graphing. We were finding a point where the two lines crossed. So anytime you have a point in the coordinate plane, you need an x and a y. Okay? All right, let's do one more together. I'll have you try this one, pause the video. All of the problems we're going to be doing this week are going to be like this, practicing this. Okay? So I think you'll get pretty good at it by the end of next week. Okay? All right, so let's do y equals 3x minus 17 and y equals x minus 7. Okay? So why don't you take a look at that problem, pause the video, and go ahead and see what you can do as far as solving it. Okay, so now we're back. All right, take as much time as you need to solve it out, and now I'm going to show you the solution. So once again, instead of doing this out with the graph, I'm going to just take the top equation and substitute it in and write it next to the bottom equation. So you're getting rid of the y. 3x minus 17 equals x minus 7. So that you're getting rid of the y so that we can solve for x. Okay? Now once again, I've got to get all the x's together, so I'm going to bring this x over here. Since it's a positive x, I'm going to subtract it. 3x minus x is 2x minus 17, and what I have left over here is negative 7. Don't forget that that minus goes with the 7. Negative 7. Okay? And now I'm going to finish this off with inverse operations. I'm going to add 17 to both sides. So 2x equals negative 7 plus 17 is 10. And then I divide by 2, and I don't have to worry about any negatives there. X comes out to be 5. Okay? But once again, remember, you're not done. If you leave like that, you're only getting half credit because we're finding a coordinate, a set of coordinates. So I'm going to take the 5 and I'm going to put it up into either equation, either one. You decide which one looks like it might be easier. To me, this one, right? Y equals x minus 7. So I put the 5 in. Y equals 5 minus 7. 5 minus 7 is negative 2. So it looks like y is equal to negative 2. So that is the point that they have in common. If we were to graph these equations, that's where they would cross. And again, you can write the answer. It's acceptable to write the answer like that. Or if you want to write it as a coordinate pair, you can do that as well. Okay? So we're going to be practicing solving these problems that we were previously doing with the graph. Now doing them out algebraically so we can be more precise. We're going to be practicing that today and pretty much into next week. Okay? So take your time. If you have questions, contact me, and have a good day.